Hello, everyone. This is the last session for today and for VTScadaFest. Right now, it's Alarm Tools and Best Practices with Alan Hudson.
Great. Who saw this presentation last year? Anybody? You'll be disappointed, Alan. Sorry. But I will say that based on this presentation from last year, it allowed him to learn some things that allowed him to now go back to his management and actually change some things around. We may, if we have time at the end, maybe a quick testimonial about what you've done regarding alarming. So what I'm going to tell you is from the salesman speak almost, because that's what I speak. But I think you can equate this to some real life stuff. And in fact, I do have VTScada running, and if we need to move over or want to move over to that, we can do that as well. So what I want to talk about really is the alarm tools and best practices, but I got to set it up in the right way. Is it working? Perfect. All right, good. I want to set it up appropriately. How many of you guys, it's kind of weird, but would you consider yourselves controls engineers? Let me see your hands. Okay, so really a number of you, but not everybody. How many are like operation-ish? Okay. How many of you guys are just ready for the announcements and the awards and getting out of here? All of us, I'm sure. My hand's up for that one as well. Thank you. Well, I want to set this up in the right way by doing this. Well, okay, I guess I should do this first. There are really four things I want to accomplish in the next 40-ish minutes or so. And I want to talk about how SCADA systems are deceptively complex. It kind of seems that way your first project or two, but the more we do this, the more complex it becomes, and yet we just fall into that mode of doing it because we've been doing it. It's like anything else, actually, that the familiarity. And yet alarm systems are so very important. We're going to talk about some standards, and then we're going to talk about how we can exceed these standards. So my first thing is this. I'm going to walk this direction. Water filtration. Who is in the water market? Okay, so what we've done with this is make it so quick and easy. Because if you look at a variety of ways of cleaning up water, and maybe I'm on the wrong side, sorry about that, Chris, on the video side. This would have been how, well, let me start up here on the top left. This is how water purification or drinking water is acquired in many, many places. This happens to be a picture that I took when I was in Zambia, and that's exactly what you see. If you happen to have a well, you know what they're doing? They've got a great common bucket, so they're standing on top of the mud, they're dropping the bucket in there, they're pulling the water out, they pour it in these containers, and they put the bucket or toss the bucket on the ground, and the next person comes up, picks up the bucket, and does the same thing. The water looks very similar. And yet, that's what they're doing. And it's no different for them. That's their way of life. Here's an early days water filter. So you have, I know you can't read all that, but grass and sand and charcoal, and you pour in the top, it just filters down into some sort of a reservoir to catch it, and now you have some clean water. Now, a lot of folks would say, I just drink it out of the creek, no big deal. Well, I did that growing up as well. You know, my teenage years, we're backpacking in the Smokies or whatever, you just did that. And now all the Giardia, or however the words you use there, they say don't do that, because even though we as humans tend to get away from the trail a bit, bears and raccoons and possums don't. So you really never know. But that's okay. Well, the next stage of this might have been this kind of a barrel. And what you can see there, I know you can't read it, but sand and charcoal and a back and forth with gravel at the bottom. And the bottom comes out with some clean water. Water comes in this way, and the water on the bottom. Looks like a gravity feed system to me that we would see in a typical water plant. If you look on the top left, that might have been, well, it would be a new type of water filtration. They're being sold all over. Thankfully, people are providing dollars and funds to get that into the hands of those that are drinking contaminated water. And yet you can use that, and it purifies it as you're sucking the water in. Again, a great, great thing. If you're a backpacker, then you very well may have seen something like this as well, where you are doing a physical connection, and you're pumping the water, and it gets down to the whatever micron level. Is a great way to go. And actually, when I was in Zambia, I took that same water up there and came back and did this right here for my drinking water. I had to clean that filter, that ceramic filter, twice a day because that's how dirty it became. Again, that would be water filtration made easy. Well, it's not necessarily that easy. In fact, if you were to go to Birmingham Water, where I'm from, go to their website, you can actually learn all about water filtration. This is the Water Filtration 101. In fact, what they have done is they've said there's a 12-minute video, and in 12 minutes you can learn all about water filtration. You can now be an operator. Not really, but at least you can learn what Birmingham Water does. But they even go further than that and say, hey, we got 9 simple steps. Here's all you got to do to purify your water. Of course, if you're in that industry, you understand it is much more complex than that. Everything that we do is much more complex than what we want to put it in the hands of the public to understand. That's really the intent of this part of the video. Is not about water filtration. It's about simple to the complex. And sometimes we make things complex for the sake of being complex, and maybe sometimes because we don't want anybody else to understand it. I think most of the time, though, it goes complex because we're finding better ways, perhaps, of making things operate. And it gets complex, and yet if you're in that business for a long period of time, it becomes simple. I'll never forget being in the integration days, and I was asked to go find the spec sheet on the pump-off relay. I looked under the P's for a really, really, really long time for a pump-off relay. I had no idea it was like relay, but nobody told me that. Nowadays, I would be much better. It's that way with everything that we do. That's what we train our children up, of course. So here's where I want to go with this part of the presentation. Legacy alarm systems. It looks like it's in Texas, although I know for sure there was a system like this in 1991 in Tennessee. And what would happen is the water would start filling up this water tank. And in fact, you may have heard me mention this the other day. No, it was in the training class, sorry. Anyway, the water fills up the water tank, and when it comes out of the overflow spout, Mrs. Smith would watch her garden. She had a little irrigation system set up, so it would come out of that overflow spout, come down through the pipes, water her garden. When her garden was fully watered, she would call the water plant and say, the tank is full. And then they would turn the pump off. No kidding, that's exactly how it worked. Now, occasionally, she had a gravel driveway. Occasionally, when she needed new gravel, guess what she did? She let it run longer. And now the driveway gets a little rutted out. They bring new gravel and scrape her driveway. Honest to goodness, that's exactly what happened. She was not happy with the SCADA system, but that's not my problem. But that was the way she operated, or they operated, I should say, their tank and their pump. Now, granted, if they had bothered or if they had didn't have Mrs. Smith, they would have had to get in the car or the truck and drive about 12 miles to check on the level of that tank. Maybe they could have said, well, I think the tank is about, halfway full, so we can let it run for 2 hours. They might have an idea, maybe. But that's what they would do. So we go from that kind of a system to this kind of a system. Now, all of us gray hairs, no hairs, I call us. Anybody not recognize this on the screen? All right, I think some of you are lying, but that's okay. So here's the deal. The alarm enunciators that we had in the old days, you remember the mosaic graphics as well? Remember if they ever fell out in transit, how you had to go back and put it back in? You ever had to do that? Awful fun, though. I mean, that's what made life grand. At any rate, what would happen is this. Alarm would come in from the field, and it would make that meh, 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 or whatever pitch sound it was with that horn that was on there. Some were obnoxious, some were just ear-piercing. And then what would happen is that light would flash. And then somebody would come along and they would press that alarm silence button, or the acknowledge or silence, depends on which one it was, and the light would go steady. What that meant was the operator had gone over there, had acknowledged it was flashing, he pressed the acknowledge button or the silence button, it now went steady. And now when the technician came by and said, oh, by the way, you need to look at, whatever that alarm happens to be. And then they go and they work on it a bit, and then hopefully it works. And then a little bit later on the day, it may go off again, and that's okay. It continues on. On a Saturday, however, during a ball game, the third time that thing goes off in the same 2-hour period, what do? Oh, yeah, You go over there and you pull that card out about 1/8 of an inch. It almost looks flush, but it was no longer going to bother you. You have disabled that alarm. Many times, I came into a situation at a plant where they say, no, everything's working beautifully, and then you would find where they had unplugged one of those cards. Again, it was just what you did if you were working in the plant. You needed relief to go do something else. But yet, that was a whole lot better than waiting on Miss Smith to make a phone call. So that was how that was operated. Now, let's go to the next one. And this is how I'll just say legacy alarm system. So if I go back to Miss Smith's example and you replace that with a computer-based, in that days it was actually DOS-based, a SCADA software, the idea was you had a banner on the bottom, alarm banner typically, and maybe a trend window somewhere, and that's just the way it operated. And so the alarm would come in, they would go over there, they would hopefully acknowledge it at some point. You kind of had to get the bell or the alarm horn to stop. And then the printer was always had paper in it and it had ribbons, fresh ribbons. Yeah, I'm just kidding. They would not always have that. You hope they did, but it really didn't. It would feed through there and go into a box. And what would you do when the box was full? You'd tear off the paper. You'd take the box into the storage room. You put it in the corner or on top of the previous one, yeah. And that would just go on. Again, was it better than it was before? Absolutely. At least it was a record that someone had acknowledged that alarm. It means that somebody had not pulled the card out and disabled it. It went off at some point. And that was a real common way to do things. So learning from those other ways of alarms is how we've ended up where we are today. And so on that one, I want to talk about the useful part of alarms. I was intrigued yesterday with the presentation that Mike Stout gave. He talked about the high-performance graphics, and I think it was like 48%, as I remember right, of issues were handled before the alarm came in because of the high-performance graphics. I think it was only like, 9% or something without that. Very intriguing. I had not seen that statistic. But the whole thing is they're using information, in this case using alarms, for things that are useful, for operations in this case, for maintenance, operational adjustments, plan procedures, management decisions. Should we manage off of alarms? Probably not. You probably want to manage off of other data first. But when alarms come in, then you can take additional action and maybe even cues you in on the next stage of that. So, as we move a little further forward, ISA did a long-term study. Now, who's familiar with ISA studies? Okay, how long do they take typically where they're studying these things? Do you know right off? It sure does. And so it does, years, yeah. So what they'll do is they'll accumulate or they'll gather people from different industries and different walks of life in that world, and they'll study. They'll get together. They'll study. They'll do statistics. They will log things. They'll talk to many folks. Get all that data together, and try to assimilate it somehow into the right things. What they came up with for alarm systems was this: no longer is it just, well, gee, the alarm went off. Let's start defining some pieces around it. So, for example, the definitions of what an alarm is. If we were to all ask the questions ourselves, what's an alarm, we would get however many different answers right here. So one quick question I have, self-revealing by the way, how many people have a check engine light on their car that just continues on? Anybody besides me? Perfect. Yeah. Probably O2 sensor related or something along those lines, you know. Yeah. Who has an OBD connector you put in there to read your things? Of course, yeah. And so you look at it, you go, oh, I can ignore that one. Yep, and even on your phone, of course, you have the Bluetooth one now. You just plug in, it's there all the time, right? Yeah, and you do that, and you go, you know what to ignore, you know what to pay attention to, you know when to stop by the auto parts store and pick up the piece that you need to fix it, okay? Very commonly done. I do have some cars with the check engine light. What drives me crazy, though, is one of my kids is driving the car, and there are no check engine lights. And then they show up at home 3 or 4 or 5 days in a row. I drive the car, and I say, whoa, check engine light's on. In fact, it maybe was riding, rough. You ever had that happen as well, where the ignition coil goes out or something? And I was like, how long has it been doing this? Oh, I don't know, Dad. I noticed it last week one day. Every car has one of those orange OBD connectors. It takes like 30 seconds to check it out, but they didn't bother. So I didn't know it was all that important. That's where definitions come into play. Maybe I didn't define well enough for them. If this happens, do this other thing, right? So anyway, we look at alarm systems. We look at the requirements of what alarms. Then they started categorizing alarms into classes and then roles, and then rationalizations and priority definitions. The one that I love the most is when they came into rules around shelving and suppression. We're going to talk about that in just a moment. Then, of course, requirements and change management, training, whatever. And there were another whole host of items that they came up with. But those are the ones that you find most often if you do a search on ISA 18.2. And if you do that, you'll come up with one of these diagrams here, and you can look at it. And it's a recursive process where you go through and you keep evaluating your system. Now, by the way, every single person's system is unique. Yes, they're all similar, or most are pretty similar, but they're all unique as far as how you're going to respond to various alarms, okay? So let's keep going with this for just a moment. The reality of what they did in part of one of their studies, you probably can't read all that stuff there. I'm going to walk on this side, Chris, and since you're videoing again. Oh, cool, I love it. You're a good camera. So anyway, anybody else got a lock on me? Perfect. All right, so I got my eyes on you. All right. So what they did there is they said, if we look at different industries, they got oil and gas, petrochem, power, let's put ourselves in the most conservative category of other. And what it says is this, that, the average number of alarms coming in per day to any given system is 900. Perhaps yours is less or yours is more, or the system you just got finished doing is more or less. That's okay. That's how many alarms are coming in. Average standing alarms were 35. So alarms that were showing up, they're in that banner, that they've been acknowledged to get the stupid horn to stop, but no action has been taken against it. So it's still an alarm state. Peak alarms per 10 minutes, it says, as many as 180 coming in every 10 minutes, or in a 10-minute interval, I should say. And then here's another average of 5. That'd be the average number coming in over 10 minutes. That would be 1 every 2 minutes, wouldn't it? Then forget the distribution. They got it, how they got it situated out. What happened, what they realized, I should say, is that an average operator could handle 1 alarm every 2 minutes at the most. So what does that really mean? It means that the alarm comes in, they would acknowledge the alarm, and then take the appropriate action based upon that alarm. Is it to call Bubba to go take a look at something? Is it to go now start something or stop something? To go now and write something in a logbook? Whatever that action may be, 1 alarm for every 2 minutes. So you could actually take that now and say, wow, if my system then that I'm either working at or interfacing to or whatever is having more than 1 alarm every 2 minutes, I might want to take a look at how that's designed. And can my operators really keep up with that? They would call that operator fatigue, by the way, operator fatigue. What they came out with was a recommendation of what kind of alarms and the percentages. And maybe it's too low for some of you guys to look at. But what it says is they recommend no more than 5% of your alarms to be in the critical nature, being you got to do something right now. That's critical. No more than 5%. No more than 15% are high alarms. Like you really got to look at doing something pretty quickly here, but it's not critical yet. And then 80% being warning alarms. Okay, put these things in your to-do list and go take a look at all that. They also came out with 2 other things. One would be a notice and one would be an event. So basically, we would say most of your alarms coming in are probably something to notice. If they're being processed right and distributed to the right people, they'd say, take note of this. And by the way, you need to, because this happened, you need to probably plan something next week or the week after to take some preventative action, maybe some maintenance, maybe something along those lines. Maybe look at your controls, how things are working, that it might be a problem. And if you see those things coming in more frequently, then you take appropriate action and move it up your to-do list perhaps. But you really don't want to have any more than that on your true alarms. Now, who went to the alarm notification class before that Greg gave? Good class. So help us out here. When he was showing it within VTScada, what class of alarms or options is a checkbox for dial out? 1 or 2. This would be a 1, the critical is a 1, and high is a 2, okay? In that terminology. And by the way, that makes a lot more sense here in just a moment on the 1 and 2. Let's go to the next page. This is even, okay, a little more complex. This is a sample, but let me just show you what the relationship is. It's looking at the impact on the I guess that's the Y versus, right? Where the lowest priority to the lowest priority to the highest priority for the impact, and then you look at on the right-hand side, going from the highest level to the lowest level on the schedule priority. The bottom line is this: if you have something that is a high schedule priority and a high impact priority, the work stops. Pump breaks, valve won't open. Those are big things. Car won't start. Those are things that impact the work, right? And also looking at the next one over, it might be a regulatory or an audit finding. Again, I know a small print there. Program directives. And you can find all this by looking at ISA 18.2, by the way. Those are real matrices you can pull off of there. But then you have the significant ones. What happens to production? Production in some worlds is different than the production in other worlds. All the way down to, hey, watch this item, not technologically feasible at this present time. Again, watch it, let's pay attention to it, maybe somewhere down the road. Maybe the next upgrade 2 years from now, make sure you have a note about that you want to pay some attention to it. But that would be an impact and priority relationship. Another one, which is really hard to read, and I apologize for that, it is not the projector, it is actually when you take a small thing and try to blow it up better. But what it on here, and again, this becomes a consequences of action or inaction for your particular application. And what it goes into is basically 3 different areas in their case: a personal area, environmental, and a financial. So the personal side is the consequence of doing nothing versus the consequence of having something really severe. Okay, all the way across here. So for example, in the personal side, the worst, the most severe is somebody gets hurt or killed. That is never a good time at a plant or anywhere else for that matter. Environmentally, you're having a spill, for example. You're having something released. Now you have people on the news. Again, never a good thing to have. You want to keep the management off the news. That's our goal. And then finally, on the financial side of things, how much is it going to cost you or cost somebody? Is it something you get sued about, or is it just a huge amount of money you got to pay to fix something else? Those become conversations inside of a group, I will say, that's addressing a problem. One size does not fit all. Every one of those does on their own, has to look at it on their own. And so you can look at all that and determine what your alarm system needs to look like. I would dare say, though, in most of our SCADA systems, anything that might be an alarm, we just, hey, it's got to be a high alarm, let's go take care of it. Or critical alarm, we just put in there as alarm and let it be gone, and not really pay a whole lot of attention to it from that standpoint. So as we continue on with this, the analysis of alarms, I think, is the most important portion of what we got to look at. So you'll just notice some various colors here. I think it might have been addressed a little bit yesterday as well in one of Glenn's talks. But what that ISA 18.2 addressed was not only operator fatigue, but also visual challenges. Who in here is colorblind? Well, at least one, good. Tip 2, we have typically, I think, according to the stats, 1 out of 7 people is colorblind. It seems like in our water, wastewater, or controls world, we have much lower percentage of that. But that could be a big deal. So maybe you can't tell yellows and from oranges and reds. Maybe it's a blue and a green, or purples. So now all of a sudden, the whole visual piece becomes an issue, or could be. But you might can tell something is highlighted. Look on the far left-hand side. Not only do you have a color for the row, you also have numbers associated with that. And so here it would show, for example, a 1, 2, 3, or 4, based upon if it's a high, a critical, a high, a warning, a notice. You also would have shape. So here is also a square versus triangles versus, or diamond rather, and then a triangle, then an upside down triangle. All of a sudden, those become things that an operator can look at from the visual standpoint side of things. But the bottom line is, if I'm just having a list, it doesn't do me a lot of good. We heard, if you were in this room, the last session, Glenn was talking about IIoT stuff and talking about data analytics. And they always seem to throw data analytics in there as the real key, if you will, for data analytics. Let me show you what has been done in the world of of alarming. I find it very, very fascinating. And so when I do a lunch and learn or a presentation or a SCADA shootout or whatever, I usually start off with other things, but I always end up at the alarming piece. I always kick myself and say, no, I should have made that higher up in the list. But I almost think about it last because I'm kind of groomed to think about that last, unfortunately. And yet, what I've noticed is that in most of those instances, especially where I have operations people, they look at this and go, wow, this is where I want to make sure we go to on the analytics part. So in this case, what this is showing me is a list of bad actors. Bad actors being, here are these alarms that came up. And by the way, it's telling me not only the count of alarms, how many times it's been off. In this case, it's looking under the filter in the middle there. It's 30 days. So in the last 30 days, that tank high level has been off 14 times. And what's the next one? The tank 2 high level went off 5 times and tank 3 twice. So think about it this way. What if you go off on vacation on Friday, you come back Monday a week later, you've been gone about 10 days now, and you come in and the first thing you're hit with is the plant manager says, dude, this is terrible. These alarms have been going off the entire time you've been gone. You go, huh, let's go check it out. And so now you can look and see really how many times did it go off. So let me just go to my VTScada application for a moment and just show you. I know it's going to be a little bit smaller to see, but that's okay. So I'm looking at a water plant, for example, or water distribution in this case, or I can go back over here to this one here. That's fine. I want to key on the alarm summary area. And if I look at my normal set of alarms, you can see there's tons of them. And actually, this is a demo running. So you got the same 4 or 5 alarms all the way through there, and that's by design. So I have something always going off an alarm. But here's where I want to go to, and that is under current alarms. I have 3 of them. Granted, one's a turbidity, one's a high level. The other one's a default call-out alarms. That's one I could force to make happen. But if I click now on this reports and analysis icon up here, what it shows me that I'll go through the last 10 days. That in the last 10 days, that turbidity alarm has been off 147 times. Do you think I might have a problem with that turbidity transmitter? Yeah. If I'd been gone for 10 days and that same pressure transmitter is showing odd levels, high and or low, do you think it might be a transmitter or do you think it might be a controls? I don't know until I go check it, but I have a clue where to start, don't I? The second one there is actually a wet well high level. It's been off twice, and then you have the disabled call out. But it also tells me what percentage of time. So again, if I'm walking into a typical plant, what did it say? 900 alarms is average in a day. Most of those being hopefully not high or critical. They're like warning or notice. So I'm looking at those alarms. I filtered on giving my critical and my high, and now I can see which ones have been going off most often in that time period looking at for 10 days, for example. Would that be beneficial? Absolutely, I believe so. And then there's some more things you can look at there as well. That's okay. What I want to look at it from this point is the alarm flood. So this is doing a real-time analysis off that alarm database. And what this is saying is, gee, in the last 10 days, here are the days and times or the range window of time that alarm's been going off. If I know that on Tuesdays I keep having a well level high at 3 in the afternoon or between, say, 3 and 7 in the evening, do you think maybe I want to go out there and take a look at that, get there at 2:30 to watch it and see why that's happening? Absolutely. So now you can start to look at the root of the problem and not just solving an alarm. There's some more stuff there. We're going to move on past that for this purpose here. And that is, I want to take this turbidity warning. That one's been going off a whole bunch. Anybody not in the water industry? Anybody? Okay, so the turbidity is basically the cleanliness of the water. Does that make sense? So what will happen is you've got your clear water there. It's sending some sort of a light signal based upon the reflectivity, based upon particles, blah, 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 blah. It gives you a turbidity unit. NTU it's called, okay? That's just the idea behind it. So it's looking at how clean the water is. So let me look at this point, this high warning. I'm going to click on that point, and I can actually go look at the properties within VTScada. I can look at what's causing it, actions and displays and whatever else, and that's fine. I could also, as Glenn was showing earlier, if you happen to see this one before lunch, I could right-click and say, hey, you know what, let's look at the page where that's coming from. So we can now go click on one of these other displays and see where, what else might be attached to that point. And those are all great and wonderful parts. Glenn showed a few other things as well on alarm configurations, but that's not necessary for now. But I want to right-click on this, and I want to go down to, I could go to plot, and we could show the plot of it. But here's the real thing. Show my details. And what this tells me is the details of that point. Very good to know. It's like, oh, somebody set it up wrong. I could look at that, of course. And the configurations of that point. Here's the real thing, the real cool part for me, statistics. Looking at a single point now. What the single point is saying that, hey, today, that turbidity has gone off 43 times. Granted, it's designed to do that in my demo. However, if you were to look at that high level, high pressure, whatever the alarm point may be, and you see that, hey, this thing's gone off 16 times today, that'd be great to know. How about the last 10 days, 148 times? Okay, I went off on vacation for 10 days. I come back, they said, man, that thing's been going off all week long. You look at the last 10 days and it says, well, 3 times. Okay, maybe it wasn't all week. Maybe it was just at the worst time. We're having a meeting to go. It's like I was always having to get up and go turn it off because it was at the wrong time. Still, you need to pay attention to it, of course. But this gives you some analysis on that point. Now, all of a sudden, you can take appropriate action. Maybe you need to assign a different person. Maybe you need to order a part. Those kind of things become very real parts. Here's the other part of that analysis that I think is so powerful, is I can put a note in here. I say, you know what, let's go ahead and add a little note. And I could put in here, let's see here, keeps alarming. We'll just say, maybe not every, I'll just say keeps alarming every 10 minutes. And then we'll say something like, George is going to look at it and make a recommendation. Okay? So whatever that note may have been, it goes in here, add it to my database. And if you'll notice, why did it not show? Did I click on the wrong thing? I think I may have. Let's add that note again. I was blah, blah, blah. There we go. And so it didn't, that was really not BLAH either. But anyway, you see on the right-hand side, there's now a little icon. I know you can't see it from where you're sitting. But the point of that is, as an operational staff, I now have had a chance to look and see it's been going off. And here's the action that's being taken. The great thing about the way alarm summaries are being done, I'm not writing it down in a notebook per se. I'm not taking that ream of paper going through the printer and having to write a note on it about what's happening. I don't have to go search in the back room. Where's that box? I know it was a couple of weeks ago. Where's that box? No, all that goes away. It's now all electronic. Now you can search it, you can query it, you can print it out, and those kinds of things. You have a real record of what took place. Let me take it a step further. Here's one of my favorite things. So I'm going to go to shelve. A shelve would say, you know what, let's just go here for the last, I'll do it this way. All right, so George is going to take, I made a note, George is going to take a look at this thing. And then George comes back and he says, you know what, let me start back again. The alarm goes off. Hey, George, where are you? Oh, man, I just went to lunch. I'll be back in about an hour. That's what will happen, all right? So you say, you know what? I'm going to pull that card out and remember to put it back an hour from now, right? No, it never happens that way. You say, you know what? I'm going to snooze this thing. Here's my snooze button. I press OK. It is now off my list. That's the ultimate snooze button right there. The cool thing is I actually have a menu item that says shelved. And that shelved shows a list of all the alarms that I have now put into shelve mode or snooze mode. At the end of that time period, being 1 hour in this case, it's going to alarm me again. It's going to become active and ring the bell or sound the horn or make the phone call. Here's the other part that I think is so powerful. While we're in snooze mode, what happens if this alarm goes off 3 more times? In our case, it actually logs those to the alarm summary. So I've shelved it, meaning the operator's not going to be annoyed, but the alarm is still being logged. Because at some point, DEP may come to you and say, hey, what's going on here with this, this alarm point? Why is it not being logged on your printer, for example, or in your log, or why are you not paying attention to it? Oh, it is making a note of it. However, it's not showing up in my log. It's not bothering my operators, but I am storing the events. Does that make sense? That would be the shelf, okay? Let me show you the next part that I think is so cool. I'm going to unshelve this on purpose. Let's say George comes back from lunch. Thankfully, he comes back from lunch in an hour. It alarms. He goes and looks at it. He tries to calibrate it. It is just not holding the calibration at all. He says, you know what? This thing needs a new part. Maybe it's a new bulb or sensor or whatever. So now he says, I'm ordering this thing off the internet. So here it is. It's a Thursday at 3:08 or 4:08 p.m. And I'm putting this thing in. I've ordered it off of wherever. It's coming in FedEx, but it's not going to be here till Tuesday. So he's going to right-click on this and say, let's shelve this guy until, let's go pick the date of next Tuesday, the 22nd, until UPS will run at, we'll say 10 a.m. I press OK. Guess what? We now have that alarm shelved until Tuesday morning at 10 a.m. Does it still log? Absolutely. Can you still prove to DEP you did the right thing? Yes, you can. Does it even log, by the way, who just did all that? Yes, it does. In fact, I didn't sign in on this. If I'd signed in, you would see under user up here, it would have said Alan. But it's logged. And yet every time it goes off, it's still going to keep a record. And Tuesday at 10 a.m., it's going to remind George you'll take care of this deal. So that's one of those neat things. Let me go back to where I was supposed to be. And by the way, if we had pulled the card out, let's just say we're no longer using that turbidity, we could, or maybe, you know, it's broken for forever. I don't have to delete the tag. I could actually just disable it, and we could do all that as well, but I'm not going to deal with that right now. I want to go back to my PowerPoint because I was supposed to do that already. I think I got ahead of myself on purpose. The other part, of course, is the alarm systems everywhere. Who do we say that went to the alarm notification class today? The configuration. It's very simple and easy. You just got to have your list designed correctly. You got to have your device, whether it be a telephone modem, an SMS text, emails, whatever, and it takes care of all that. We're not going to spend any more time on that. Here's where I want to finish up, and that is as I'll say a collective group here of controls engineers or controls people, that we got to make sure that as we do our architectures of SCADA, that we know they're always going to evolve and move forward. And they're going to seem to us to be pretty straightforward because we're solving an issue, adding to an already complex system perhaps. We need to understand that, and maybe the new person coming in doesn't understand the complexity. So there may be some documentation we need to do for that. In some cases, like in what Alan was saying, or before, is that things were done some period of time back, and we're left alone, and the people that asked for it to be done that way are no longer in those roles, so they're saying, wow, maybe we should do something differently. Or, gee, why can't it do something else? Well, there's a reason behind it usually, so knowing that. The next thing is, there should be a tool, a critical tool, it says on the slide at least, and not just a nuisance. That's the truth of that. How many times have you been told, us old guys, by your child perhaps, hey dad, your blinkers on? Anybody been told that besides me? Anybody told that to their dad? Come on. Everybody's told it to their dad. In the old days when they didn't automatically go off, we all said it. Come on. All right. Anyway, you know who you are. And then the next thing is, by the way, I say embrace technologies. Just so you'll know, Alan Hudson is not an early adopter of technology. I'm there before it gets to the peak, but not a whole lot before. I'm on the leading edge, but not the bleeding edge. Some of you folks, however, are right there in the front. Overall, I remind myself of this all the time. Embrace those technologies that are going to work for you, but do it appropriately, knowing the environment that we're in and how critical those things are. Then finally, manage the system and don't let the system manage you. That should be our goal with all of this. It's not about some alarm that goes off and I just begrudgingly press the silence button. It's about how can I utilize that to make not only my life easier, but make the plant operate more efficiently, to make the manager's life better, make the equipment last longer. All of those things together should be where we're going with that. So with that being said, are there any questions at this point? My normal part of the presentation is over. Questions? We have just a moment, Natasha, if you don't mind. We got 5 minutes. Would you want to share just for a moment about what you experienced? Is that okay? Can you do that? Or would you rather not? Okay.
No, I don't mind at all. All right. So my name is Alan. I work down at the Loxahatchee River District down in Jupiter, Florida. Last year, when I was at this presentation, learned about the analysis tools for the alarms. And it was interesting. So last February, we're going through a construction project. They were adding some deep bed filters. And there was a time when they turned the system online to running it, making sure everything was good. And at the same time that they sent all the flow, we started getting these alarm anomalies. And looking at the analysis tool, after about a month, when I finally heard about it, it was like 1,000+ alarms a day. So it was like high volume. And it was actually, like, they mentioned it, and I said, well, go check. When they first saw the alarm, I said, well, go check. Maybe you're hitting a cavitation point on an alarm or something on one of the pumps. I said, just see if you're outside the range, and that's why it's backing off, doing whatever. It turned out that one of the night operators, because operators talk all the time to the SCADA technician guys, it actually went through management, and it came around to another meeting. But basically, one of the operators was complaining about this nuisance alarm. And so I was already looking at this data, already had one of our programmers looking at the PLC application. And it turned out that this alarm was in service since 2008, but they changed the hydraulics of the plant. So therefore, the alarm was just constantly going off. And basically, it was an alarm to notify the operators that the flow to a certain pump station it was 500,000 gallons less than target, but they kind of diverted that to the deep bed filter. He was going through I don't know who's familiar with like a synthetic media filter where it's constant flow and it's an upward filtration. Well, that was the design. It's fixed flow rate, and then they put it to a deep bed filter basing off of a remote tank level, and so it just kept on going, fluctuating all day long. Anyhow, it took us a few months to figure out what was going on because I wanted the guys to talk to the developers of the application. They ended up talking to management, who came down in the wrong aspect. But it was like, we already knew this was going on, and it turned out to be that one alarm, and we got it fixed. And it's interesting how now once that alarm is gone, everybody's back to being happy again. But it taught us one crazy thing is we have so many alarms that, number one, we're in the process of going through every area, because every area inside SCADA has alarms, whether it's chlorine contact or a lift station 2 or whatever, doesn't matter. And just going through all the alarms and seeing if you really need them anymore. Because when an application is 20 years old, you guys acquire so many alarms because people say, it would be really cool to have an alarm that does this. And sometimes they want it as a priority 2 and a priority 1 because those are the only ways the technician gets notified. It would be cool if I can do like maybe a 3 or a 4, just like I can't call you, but I can let you know in a report somehow.
Right.
Right. But I haven't figured that one out yet. I'm sure there's a way to do it. But yeah, you have to go through your alarms because you just acquire so many over time.
Very good. A lot of good practical knowledge there.
Yeah.
Thanks, Alan. Yeah, good. Well, guys, thanks a bunch. Turn in your stuff to Natasha. Oh, yeah, thank you.